we are starting proofs. We spent 3 days on proofs, okay? You just need practice on them. It's not that they're the worst thing ever. It's just you have to do them to get better at them. So we practice. And there's a lot of lined paper because you need to write the formulas so that you actually remember them and recognize them. So we're going to start with your notes for Standard 20, the basic identity. So the first group is called the reciprocal. So your first one is cosecant of theta equal to 1 over sine of theta. These you should be familiar with. Secant is 1 over cosine, and then cotangent so these are the reciprocals. And then your other basic ones here, we have the quotient identities. Tangent of theta is sine of theta over cosine of theta. Cotangent of theta is cosine over sine. Hopefully those are all somewhat familiar to you, okay? We've worked with those for a while now. So guys, yes, you will have to know these. What we do at the end of, like what you'll do on your quarter test, and we're probably going to assess you on knowing the identities, and then you'll be able to use a formula sheet on your quarter test. But I need to know that you know the formulas going into that, okay? So we'll talk about what you'll get on each standard as we go throughout them. But if you're doing the practice on all the proofs, you're going to use these enough that you know them. And if you don't know them, it's really hard to do the proofs because you can't recognize the substitutions. That's all the proofs are, is doing different substitutions to simplify one side into the other side, okay? So these, am I right? These are all very familiar to you? Yes, okay. So the next group is called the Pythagorean identities, and these will be new for you. Okay, so let's make a little picture here so we can understand where they come from. So I drew a little triangle in here. put theta in there, the right angle in there. Are you guys okay with that side would be x and this side would be y? That all makes sense, right? We've been doing that for a while. Okay. If we're in the unit circle, what is the hypotenuse going to be? 1. Okay. All right, if you were to set up the Pythagorean theorem with this triangle, what would you tell me? Yeah, x squared plus y squared equals 1, right? Okay. So let's think about other things that we know. In terms of sines and cosines, what is x? Cosine, okay. So instead of x squared, I could say cosine of theta squared. Now, yes, the squared comes before the theta. I know that's a weird notation. You'll get used to it, though. So what do you think I'm going to write instead of y squared? Sine squared. And the 1 is still just a 1. So that right there is your basic Pythagorean identity. You will use that a lot, okay? All right, we're going to start with that one and derive a few other identities. So if I begin with cosine squared theta plus sine squared theta equals 1. Let's just jot that down. Okay, that's just my basic identity there. What if I decided to go through and divide everything by cosine squared? Is that okay? Like, can I do that? I'm not changing the value, right? Because I'm doing it to every term. Let's think about what we have left. What is cosine squared over cosine squared? 1, right? Okay. Up above, you wrote what sine over cosine was equal to. Okay, and since these are both squared, what do you think it's going to be for tangent? Yes. And guys, are you writing the theta? You need to be writing the theta, okay? That is a part of it. And then what was 1 over cosine? Secant, so this is going to be secant squared. All right, so that is your second identity from this. Okay, you with me? All right, to find the third one, let's start again with the basic identity. Cosine squared plus sine squared equals 1. What do you think I'm going to do to find the last identity? Yeah, divide by sine squared. All right, what does all this simplify to? You guys are very whispery this evening. Cotangent squared plus 1 equals what? Cosecant squared. Okay. So if you know that original one, could you find the others? Even if, like, if you don't have them memorized, could you find them? Could you write it down and find them? Okay. Along with this, we have a bunch of manipulations of these. So I'll make sure everybody has these written down, and then we'll look at some other things we could do with these. So let's go back to looking at the original one. The cosine squared plus sine squared equals 1. What if I wanted it to say cosine squared equals? Like I wanted the cosine squared by itself. What would that equal? Yeah, 1 minus sine squared. So that's another formula you could use as a substitution. Okay, one that's good to recognize. Anybody think they know another one from this? Yeah, sine squared equals 1 minus cosine squared. So these are kind of your secondary ones. Do you think we could do the same thing with the 1 plus tangent squared equals secant squared? Yeah, what if I wanted it to just say 1 equals? What is 1 going to equal? Secant squared minus tangent squared. Good. And what if I wanted it to be tangent squared equals? Yeah, secant squared minus 1. Does that make sense to you guys where those are coming from? Okay. And recognizing those ones that I've written in blue, when we get to the proofs, if you can recognize those, it's going to make your proof quicker. If you don't recognize them, you can still get to the end of the proof. It just might take you a few more steps. Okay, so they're just helpful as far as speeding things up. So we've got 2 more to write. What is 1 going to equal? Sure, we'll do the 1 first. What will 1 equal? Yeah, cosecant squared theta minus cotangent squared theta. And then our last one is cotangent squared theta equals cosecant squared theta minus 1. Okay. How we doing, guys? Hanging in there? It's a lot of writing formulas before we get to anything to actually do. Yeah. Is there what? I'm sorry. A specific what for the blue one? Oh, they're just other versions of the Pythagorean identities. So these all fall under that same category. It's just the red ones are kind of the 3 major ones, and then the blue ones are all the manipulations of those, okay? But they all go together. Okay, let's try some proofs. All right, so first one, we're going to prove that the cosine of theta equals the cotangent of theta times sine of theta. So write it down, and then let me talk to you about a few rules that we have to do. First, you are going to work vertically. Draw a line here. So it's going to be a step-by-step working down the page kind of process, okay? You will work vertically. Second rule, you cannot cross the equal sign. So what that means, you guys are used to, if you solve an equation, you could like add 2 to both sides of your equation or multiply by 3. You can't do that in a proof because we don't actually know that this is equal, so those properties of equality don't work. So you're just going to do a bunch of work on one side, maybe some work on the other side, until you get the 2 sides to be the same thing. Okay, so it's just a bunch of substituting and simplifying until your sides match. Okay. Your third rule, do not sit and stare. The only way you get better at these is by actually trying something. So don't be afraid to write something down, and if it doesn't work out, okay, then you go back and try something else. But if you just sit and stare, you're not going to get very far, okay? So try something. And we'll do a bunch of different practice proofs here and kind of see how they work. All right, so this first one, I've got cosine theta, and I'm trying to turn cotangent of theta times sine of theta into that. So let's think about something we have a substitution for. Could I rewrite cotangent as something else? Yeah, what do you think? Cosine of theta over sine of theta, good. So what I show up here as far as the work, that's what I need to see on your paper. The answer to these is not like just the final step. I check your work all the way down the proof, okay? What do you see that's going to happen now? Yeah, the sines cancel. So I'm left with cosine. And I'm going to write equals and bring down my cosine from the other side. You have done a proof. Very different from geometry proofs, right? There's no like step and reason and name a theorem and all of that stuff. Okay. Questions on the first one? They're obviously going to get trickier than that, but that's the general idea of how they work. Okay. All right, let's try a second one here. Let's do sine of theta times cotangent of theta all over cosine of theta equals 1. You guys want to try it? Okay, try it, see how you do, talk to each other. Make sure you don't leave stuff out and have it reappear later in the problem. All right, compare with your neighbor. What's wrong? Oh, well, go ahead and finish. You got a minute. We're not in a rush. On the assessments, you'll have enough time to do them. These are going to be weird doing as standards. Just like to pick one of these to have to do is going to be a little weird. So figure it out. Well, we don't assess standard 20 for a while. Until next week. Which is when you're gone, I know. You'll be fine. You really will. We'll figure it out. All right, guys, let's look. So I'm going to turn cotangent into cosine over sine. If you want, you can write your sine over 1 if that helps you keep it organized. Now what I meant by don't have things disappear and reappear, make sure you write over cosine, okay? You can't just like do a bunch of work in the numerator and then have the denominator reappear later in the proof. Every step has to be equivalent to the previous step. From here, I see that these cancel. So I now have cosine over cosine, which is 1. That's the amount of work I would need to see. Okay, so yes, you have to write the step cosine over cosine, and then 1 equals 1. Does that make sense, what I'm looking for here as far as work? Okay. These are pretty simple so far, but when we get into the more complicated ones, usually there's many different ways to do them. Some are quick, and sometimes you guys like the long route. Like if I'm asking you to take something next door, you could walk out the door, turn right into that room. You could also walk out my door, go left, down the steps, out on the track, do 2 laps, come back up, and then go next door. You still get to the same destination, you just take a longer route. Sometimes you guys do that with your proofs. Some of you like the long routes, but that's okay. All right, let's look again. Did we do okay on that one? Okay. Starting fairly simple. All right, let's do this one. Sine of theta times cosecant of theta equals cosine of theta times secant of theta. This is one where if you want to work on both sides, that's going to be easier, but you still can't cross over that little wall I drew, okay? Check with your neighbor if you're ready. Okay, do we know that cosecant is 1 over sine? Secant is 1 over cosine. One equals 1? Yes? Okay. So again, knowing those substitutions makes it much easier.
So did you not have to, I put sine over sine as a step, but then you can just cancel?
You can just cancel since we're multiplying, yeah. If you wrote it, that's totally fine. Yeah. And when in doubt, show the step. So. All right, any questions on 3? Get there? Yeah? Okay. So far, not bad, right? All right, I'm going to throw a little more at you this time. All right, let's do cosine of theta equals 1 minus sine squared theta all over cosine of theta. Guys, what jumps out to you in this one? You see that it's squared, right? Which formulas did we look at that always had a square in them? Pythagorean, right? Okay, so I'd look at those. Is there anything you can do with that? Is 1 minus sine squared equivalent to anything? Give you a minute. Not sure. Did you write all the variations?
Yeah.
1 minus sine squared equals something. Okay. What if you had x squared over x? What would that simplify to? So what do you think? That can simplify too. Just like you can do that. Well, what's the left side? Okay, we'll look. All right, guys, let's look. Okay, did you recognize 1 minus sine squared is equal to cosine squared? Did you guys see that in your Pythagorean identities? Okay. All right, from here, guys, you don't have to show this step, but I want to make sure you see what's happening. Isn't cosine squared just cosine times cosine? So then what happens? Cancel. And you're left with cosine, which is what we were trying to get to. So this step right here, you can skip this. And you can just reduce from the previous step, okay? But I want to make sure you see what's happening, yeah.
If the theta is looking at the square, why is it still?
So what cosine squared theta means is cosine of theta times cosine of theta. If you saw that, that's actually just the angle itself squared. Okay, does that make sense?
Yeah.
I know the notation's weird, so that's the one you're going to see though. Okay. All right, are we okay on that one? You see it now. Let's try again. All right, 1 over tangent of alpha equals cosine of alpha times cosecant of alpha. So guys, lots of different Greek letters will get used. Theta gets used a lot, alpha some, you'll see beta every once in a while. Okay, so don't panic if you see a different Greek letter. Sometimes we just use X's and Y's, okay? It's just alpha. Sometimes people will draw this as a happy little fish, okay? All right, try this one. Nothing squared, so you won't use your Pythagorean identities. It's sine, sine, cosine. Very good. Most of you are getting there. All right, so on the right side, are we okay with cosine times 1 over sine? Think about if you need to write, this is over 1, and then remember how you multiply fractions. Numerator times numerator, denominator times denominator. You have cosine alpha over sine alpha. As you're working through these, if you get to that point and you're like, okay, I don't really know what else to do with that, maybe I should look at the other side. Okay, or if you recognize what that is, that's great. What is 1 over tangent? Cotangent. And what's cosine over sine? Cotangent, okay. You're there. They're like little puzzles you just have to figure out, okay? Any questions on that one? Okay, are you ready for a tough one? Let's see, do I want to give you this one? All right, ready guys? This is the last one in your notes, and then we'll probably do a little bluffing game. Bluffing? Bluffing. All right guys, this is gonna throw some new stuff at you, okay? Sine squared over 1 plus 2 cosine theta plus cosine squared theta equals, how hard do we make this? All right, cosecant of theta minus cotangent theta over cosecant theta plus tangent theta. All right, guys, there's stuff in this one that you haven't done yet. Well, it's algebra skills that you know, but you haven't done them with all the trig stuff. So I'll give you a couple of hints. Things that you're going to have to do in this one, you are going to have to factor. And you're going to have to deal with finding, like, well, actually they already have common denominators, but deal with adding and subtracting fractions and all that goes with that, okay? And Pythagorean substitution, there's a lot in it. Guys, this is the part that you have to factor. Don't substitute anything into that, just try to factor that, okay? You actually have to factor the numerator eventually too. But. So I'll give you a couple minutes and then I'll walk you through, but I want you to try. See if you can get somewhere. Remember, sit and stare is not an option. Try something. Work on the right side. If you're like, man, I don't have any idea what's going on the left side. See where you can get on the right side, okay? Try to get something. Do you see on the left how I just have sines and cosines? On the right side, I probably want to turn those into sines and cosines then, okay? Since we're trying to get the two sides to match, just to help you out a little there. Talk to each other, see if you can come up with ideas if you're stuck. I'll help you. I want to see how far you can get. Yeah, a couple more minutes.
So this one. This is
Let me right up here where you probably want to end, just to give you kind of what you're shooting for. You should be able to get that on both sides. Okay. Don't break any algebra laws along the way. Some of you getting there?
I was on the way there.
You were on the way there. You're on the right path. That's good. Okay, so 2 things to factor in here. So choose like Okay, guys, let me go through it just so we have time to practice a little. How many of you think you've got there on both sides? Yes? Well, one. Okay. Good work. Okay, let's look. It is significantly more challenging than the ones we have done so far. Okay. I actually think the right side's easier, so I'm going to start there. Now, I look at it and I just think, yeah, sines and cosines are going to make sense. I've clearly done a lot more proofs than you guys have. But what I look for is what's going on the other side. If there were a bunch of cotangents and cosecants on the other side, this is probably not what I'd do as my first step. But since it's sines and cosines, I turn it all into sines and cosines. So does that step make sense to you? Okay. You guys see how it's the same denominator for all the fractions? So what this really is 1 minus cosine over sine over 1 plus cosine over sine. Okay. Do you guys recognize what's going to happen here? Let me write the next step. If you don't write this, that's okay, and you just reduce. I'm fine with that. But remember, when you're dividing by a fraction, what you're really doing is multiplying by the reciprocal. So I can flip that second fraction. And then what do you see? You see the signs are going to cancel? Okay. So here I am at 1 minus cosine over 1 plus cosine. I heard that too. All right, so we're good on the right side? That's not too bad, right? The left side's trickier. So a couple of things here. Sine squared. What could I replace sine squared with? 1 minus cosine squared. Okay, algebra rule here. Can I just cross out these cosine squares? No, these are not factors. We've got addition and subtraction going on, so you can't do that. You can only cross out factors, so we should factor. So a reminder of some factoring. What if I had x squared minus 9? What does that factor into? That's all we're going to do in the numerator. It's just difference of squares. Okay? So it's going to be 1 minus cosine times 1 plus cosine. Are we okay with that? Okay, the denominator, it's a trinomial, so I'll erase this here in a second. What if I had 1 plus 2x plus x squared? I could factor that, right? Wouldn't it just be 1 plus x times 1 plus x? Okay, so what's it going to be since I have cosines instead of x's? There you go. Okay, now what can I get rid of? Do you see now how it's okay to cross those out? And you're done. Okay? That is a much, much, much tougher one than most of what you're going to do on your homework, okay? All right, that's the end of notes, so let's do bluffing. We'll just split down the middle. Martin, I'll have you go with that side today, okay? If you don't want to do these on a whiteboard because you don't feel like you have enough room and you just want to use paper, that's fine. I can just come and check your paper if I call on you. Good. Yeah, and it's not even going to be all of them. I think just odds. Yeah. All right, guys, first one here. Okay, so remember over here, you guys are the left side, you guys are the right side. It's me looking at you, my left and my right, so I don't mess it up. I don't know who I'm going to call on first. Did we already do this one?
I said you already got, just had to see that.
Oh, then I already wrote one, yeah. This one is much easier than the one we just did, okay? No factoring involved. Thirty more seconds. All right, let's do right side. Dana, think you got it, or you can bluff me. Okay, let's see, Sean. Perfect. Good start, guys. Let me go through it real quick just to make sure everybody's okay. Tangent is sine over cosine. Secant is 1 over cosine. So that's going to create sine over cosine times cosine over 1. Sine equals sine. We good on that one? Okay. This one's a little tricky. I know that's not fair, but it is what it is. All right, cosine over secant times sine equals cosecant minus sine. And again, make sure you're writing your thetas in every step. You won't get the points for being right if you leave out your thetas. And I'll give you a hint, on the right side you have to do a common denominator for this one, okay? How we doing, guys? You can talk to your neighbor too. Secant theta times sine, and there's no. My theta line, is that what's messing you up that? Okay.
I gotta go on one side. Because
I mean, wanting to
cosecant minus sine, well, cosecant is that what it's called?
it's not there.
Yeah, it's 1 over sine. Yeah, and then
Yeah, and then
it's
that
sine
one.
over sine.
It's not sine over sine, it's sine over 1.
Sine over 1, and then you have to make the bottom sine theta, and then you have to change the top to sine square theta, and then you like 1 minus sine.
Give me another minute, guys. Sorry that I made the difficulty so unequal on the two problems. The right side is happy right now. All right, left side, you want to stand up or just, all right, we got one. One. Anybody else want to bluff? Two.
Well, since you already know it's just one daughter, I think you can call it her.
Might. Big comeback here, left side, 3 points. Let's go through this one clearly. I don't know. I wanted to give you one where you had to find a common denominator because we're running out of time, but that got kind of tough. All right, let's do left side here. Secant's just 1 over cosine, right? Okay, we're fine with that, yes? Okay, so I have cosine divided by sine over cosine. Yes? Okay, dividing by a fraction, what am I actually doing? Okay, so this is really cosine times cosine over sine. Yes? Okay. Cosine times cosine, cosine squared. You could certainly keep going on this side. I'm going to go ahead and look at the other side and see where it leads me. Does the left side make sense to you? Okay. Cosecant is 1 over sine minus sine. If I want to make that a fraction, I put it over 1. How do I subtract fractions? Like, what do they have to have? Common denominator. So don't I need like a sine over a sine here? You don't have to show me how to find a common denominator. You can just go to the next step. I'm doing it in green just so you can see what I'm doing there. So my next step, I can just write the fraction. Do you guys see how it would be 1 minus sine squared? Okay. Algebra becomes very important as we do these proofs. You have to understand factoring, simplifying, common denominators, all that stuff. What is 1 minus sine squared? Cosine squared. You're done. Okay. All right, that was a tricky one for the left side, sorry. We're about out of time, guys. So in your packet, you will see homework standard 20, day 1. Let's just do the odds, okay? So front and back, odds. If there is not enough room for you to keep it neat and organized on here, please do it on another piece